Hello all, welcome back to our deep learning series. In the previous episode, we understand what deep learning is, how it is subset of machine learning and how it learns patterns automatically from data. In this episode, we will understand the basic idea behind a neural network. We will compare a human brain neuron with an artificial neuron, and then we will see how many artificial neurons works together to form an artificial neural network. Let's start with a simple question. Why do we call it a neural network? The word neural comes from neurons. In the human brain, neurons are the basic units that help us receive information, process it, and it sends signals to other neurons. Now look at the left side of the slide. This is a biological neuron. It has dendrites, a cell body, an axon, and terminal axons. Dendrites receive signals from other neurons. The cell body processes the signals. The axon sends the signal forward. At the end, terminal axis passes the signal to other neurons. The connection point between neurons is called a synapse. Through synapse, information is transformed from one neuron to another. Now, this is not exactly how artificial neural network works. But this idea inspired scientists to create artificial neurons. Look at the right side of the slide. This is an artificial neurons. It receives inputs. These inputs can be numbers. For example, if you are working with an image, the input may be a pixel values. If you are working with a house price prediction, then the input may be a street, number of rooms, location, and age of the building. Each input is multiplied by a weight. Now, what is weight? A weight tells the model how important that input is. For example, if you are predicting house price, the location may be more important than the color of the wall. So, the model gives different importance to different inputs. That importance is represented by weights. After multiplying inputs with weights, the artificial neuron combines them and passes the results through an activation function. Activation function is very important. It helps the neural network learn complex patterns, not just simple straight line relationships. Finally, the neuron produces an output. So in simple words, an artificial neuron takes inputs, applies weights, uses an activation function and gives an output. Now look at the bottom part of the slide. In the human brain, many neurons are connected together. One neuron alone cannot do all complex thinking. Many neurons work together by passing signals. Similarly, in artificial neural networks, many neurons are connected together. We have an input layer, hidden layers, and an output layer. The input layer receives the data, and the hidden layers learn the patterns from the data, and the output layer gives the final result or prediction. For example, if you give an image of dog, the input layers receive the pixel values, the hidden layers learn edges, shapes, eyes, ears, and the body structure. And the output layer finally says whether the image is dog, cat, or something else. This is the basic idea of neural network. But one important point, artificial neural networks are inspired by the human brain, but they are not the same as the human brain. The human brain is a biological, very complex and still not fully understood. Artificial neural networks are mathematical models. They learn by changing weights and finding patterns in data. Now that we understand the basic idea of neural networks, let us see where deep learning C is used in real life. Deep learning is powerful because it can learn patterns from complex data such as images, sound, language, and video. Let us go through some common applications one by one. First, smart surveillance. In smart surveillance, deep learning models can detect people, vehicles, unusual movements, and activities from the camera footage. For example, a camera can identify whether a person is walking, running, or entering a restricted area, standing in one place for a long time. This is useful in security systems, traffic monitoring, public safety, and smart cities. Second, autonomous driving. Self-driving cars use deep learning to understand the road environment. The road must detect cars, pedestrian, traffic lights, road signs, lanes and obstacles. For a human driver, this looks natural, but for a computer, every video frame is just pixels. Deep learning helps convert those pixels into meaningful objects and decisions. Third, medical imaging. Deep learning is used in medical imaging analysis such as X-rays, MRI scans, CT scans and ultrasound images. It can help doctors find patterns that may indicate diseases, tumor, fractures or abnormalities. It does not replace doctors, but it can support doctors by highlighting areas that need attention. The fourth one, speech recognition. When we say turn on the lights or call my friend, our phone or smart assistant converts our voice into text. Deep learning models learn patterns in sound waves and convert them into words. This is used in voice assistants, transcription tools, call centers, and language learning apps. The fifth one, recommendation systems. Whether YouTube recommends a video or an online shopping app recommends a product, deep learning may be used in the background. The model looks at the user behavior, watch history, clicks, likes, search pattern, and similar users. Then it tries to predict what content or product the user may like next. And the sixth, chatbots and natural language processing. ChatGPT-like system use deep learning to understand and generate text. These models learn patterns from huge amount of language data. That is how they can answer questions, summarize text, translate languages, write code, and have conversations with the users. Face recognition. This system uses deep learning to identify or verify people from images. The model learns important facial patterns such as distance between eyes, face shape, nose structure, and many other hidden features. This is used in phone unlock, attendance systems, and identifying verification, sometimes security applications. Finally, eighth, industrial inspection. In factories, deep learning can inspect products automatically. For example, it can detect cracks in metal parts, scratches on products, missing components, damaged packages, or defective items on a conveyor belt. This helps industries improve quality and reduce manual inspection time. So when we say deep learning is powerful, this is the reason. It can learn from images, audio, video, and text. These type of data are very difficult to handle using manual written rules. Now it's a quiz time. Pause the video and write your answers in the comment section. Question number 1. In neural network, what is similar to a brain neuron? Option A database table. Option B, an artificial neural that receives inputs and produces an output. Option C, a fixed rule book. Option D, a video file. Question number 2. Which is a common application of deep learning? Option A, medical imaging and speech recognition. Option B, only calculators. Option C, only spreadsheets. Option D, none of these. Write your answers in the comment section, and of course I will give you the answers right away. For question number 1, the correct answer is B. For question number 2, the correct answer is A. That's all for this episode. In the next episode, we will understand how neural networks actually learn. We will discuss how a model makes mistakes, how it calculates error, and how it improves step by step. If this video helped you, please like, comment, share, and subscribe. Thank you for watching. Have a good day.